Hello, everybody. First, I would like to thank organizers for kind invitation. I think that this conference is very for all of us who are interested in the vocalization. And for me, it's really a pleasure that I can present my work among such a distinguished researcher. Today, I will be talking about our work analyzing rad USV to test alpha-7 nicotinic receptor modulators as a potential treatment for autism. Autism is a complex neurodevelopmental condition defined by the three main features: challenges in the communication, social interaction, and repetitive behavior. Together, these features shape how each person with autism experience and interact with the world. So understanding them is key to develop more effective support and therapy. Communication is one of the biggest challenges in autism. These difficulties involve verbal aspects such as the delay language, unusual speech pattern like differences in rhythm, tone, or echolalia, but also the syntactic issue. There are also nonverbal cues are impaired, like reduced eye contact or mimic, but also the back and forth conversation. Communication difficulties can look very different from person to person, to not speech at all, to subtle difficulties using language naturally in social situation. And here also the sex matters, as men appear to be more affected than women. So there is a need for models that will capture broader communication pattern in preclinical studies. Right now, no medication directly treat any of the core symptoms of autism. The medicine we do have, like aripiprazole or risperidone, mainly target the related issues such as irritability or aggression rather than social or communication difficulties. But other drugs like SSRI, psychostimulant, or anticonvulsant drug can help manage the comorbid symptoms like anxiety, hyperactivity, impulsivity, and correct the mood stabilization. But none of them improve the communication and social behavior. So this unmet need is what drives our search for new pharmacotherapy. One of the promising drug target is the cholinergic system, particularly the alpha-7 nicotinic receptor, because evidence from preclinical and preclinical studies point to the cholinergic system dysfunction in autism, including basal forebrain abnormalities, so the main cholinergic tab, a reduced cholinergic level in the brain of children with autism, which was associated link with the symptom severity. Also, the reduced number of nicotinic subunits, mainly the alpha-7 nicotinic subunits in the prefrontal cortex. And also, there are genetic findings like micro deletion in that involve the alpha-7 gene, and lower expression of this gene further strengthens this link. Despite these evidences, direct alpha-7 therapy are still quite limited. Alpha-7 receptor has been found throughout the brain region which are involved in the cognition and social behavior. It's ligand-gated ion channel with high calcium permeability and rapid desensitization. It can be activated directly to the agonist or indirectly through the positive allosteric modulators. PAMS do not activate the receptor alone, but enhance its response when natural agonists like acetylcholine is present. We've got two types of PAM, to be honest, three, but today I will focus on only two. Type 1, which like CCMI, which enhance boost receptor response, but without altering the desensitization. And type 2 PAM, like PNO, which enhance receptor response, prolong activation, and can even reduce the sensitization when it occurs. So based on it, it looks like PAM offer more natural and balanced way to enhance signaling in the brain. They appear to be safer, have fewer side effects, and could even work long term. From our experience, both of these compounds were effective in improvement of cognitive function and social behavior in schizophrenia models, both pharmacological and neurodevelopmental. So we thought that alpha-7 PAMs might also help to restore the communication in autism. The models we choose was based on the prenatal exposure to valproic acid. Valproic acid is a mood stabilizer and anti-convulsant drug, and it has been proved that in children whose mother it enhanced the risk of autism in children whose mother received this drug during the pregnancy. As the most of the study that I found will have focused only on the male mice, we first validated this model in rats. We included both sexes and tested animals lifelong. We started from the PAM vocalization, and as you can see here, both female and male, when were separated from mother, produced fewer calls that were shorter, and while bandwidths stay at the same, the peak frequency actually increase. So prenatal VPA seems to disrupt early social signs, similar to the communication delay in autism. And here is interesting that babies cry, children cry, who later develop the autism, have similar pattern of changes. And during the adolescence, this USV deficit persisted, while only males show reduced social play. Both male and female continued to emit fewer and shorter calls with higher frequency than controls. In adulthood, the picture partially changed. Social interaction deficit and reduced number of calls persist, again more pronounced in males, but acoustic feature of calls largely normalized. So next we ask whether alpha-7 PAMs could restore function in adolescent VPA rats. And here we found that PNO boosted social play and restore the vocalization in VPA males, but we did not observe this effect from the CCMI, so the first type of PAM. In female, the USV deficit was still present, but was weaker when both PAMs were administered. Building on this result, we next ask whether alpha-7 PAMs could also reverse the communication deficit in adult VPA rats. As shown here, rats were treated subchronically by alpha-7 PAMs before the social interaction. Unfortunately, today I can only present you the vocalization data from this experiment. But this time we analyzed the calls multidimensionally to capture broader aspect of communication impairments that might be useful in autism context. And as before, we found clear male-specific deficit. Male VPA males produce fewer calls, and this deficit was consistent across the entire test session. They also show fewer call boats and less activity within each boat, what suggests that VPA disrupt temporal organization of vocalization, but neither PAM restored this core level in VPA males. Females were less affected. The reduction appeared only on the last final phase of the test, which may mean that communication deficit in females emerge with longer social interaction. Even though the number of calls went down, the acoustic features, so the duration, call duration, frequency, or bandwidth, stay pretty stable. So it looks like the issue isn't really how the calls are made, but when and how often they happen. Next, we look at the timing of the calls, and VPA males started calling later and had longer pauses between calls. Both PAMS shortened this interval, especially PNO, which improved the rhythm and the flow of the communication consistently across the entire time window. In females, neither VPA nor PAMS affect timing. In this experiment, we use unsupervised clustering to categorize the vocalization. Why? Because it is useful alternative to manual labeling, because it automatically group large data sets in objective way, even without prior labels. It can also uncover patterns that might otherwise miss. In this experiment, we use variational autoencoder built into the DeepSquid software. So the algorithm mentioned yesterday by Kevin. So in this moment, I want to thank you, Kevin, for DeepSquid. And here the UMAP plot show two major call families, high frequency calls around 70 kilohertz on the one side, and lower frequency sounds near the 50 kilohertz on the other. Within this high frequency group, we can see the very short calls. And here, maybe that would be something that Kuba would be interested, because in this group, sometimes I found also 80 kilohertz out. The next cluster contained the trill calls that may differ in bandwidth. And cluster 4 was contained from the more complex sounds. We call it as a jump calls, because it included the step calls and calls combined with flat and trills. On the lower frequency side, we find simple frequency modulated calls and short, narrow band calls, but this short was slightly longer than the high frequency one. The overall call diversity wasn't changed by VPA or alpha-7 PAMS in either sex, but we did see clear sex differences. Female made more frequency modulated calls of lower frequency, and fewer trills and high frequency short. So these differences seems to be independent of the treatment, but point to rather to the natural sex-specific communication style. Next, we use the clusters to analyze the vocal syntax, because RAT USV, as you know, follow a structure nor random sequences. And in control mice, we saw centralized transition dominated by trill and jump calls, and this which acted as a main hubs with many incoming and outgoing links. Control females, in contrast, show a more balanced pattern with no single call dominating the flow of the transition. In males, VPA had minimal effect because it looks like then this compound only the reduced number of leaks, but general pattern of transition was the same or was comparable to controls. But in females, VPA has stronger effect because it's disorganized this balance organization, shifting transition toward a simple, flatter, high frequency calls and enhancing transition, reducing transition to the lower frequency sound. what results in reducing overall diversity. CCMI, so type 1 PAM, show relatively consistent effect across condition. It's tend to increase in all group, increase transition into trill calls while reducing transition to the low pitch or flat sounds. It also in females partially restore transition to the frequency modulated sounds of lower frequency. And all of this effect was stronger, almost 3 times or 2 times in VPA animals. So maybe it suggests that this compound improve how calls are made, how calls are sequenced in a mild way, but this is the question. Second type 1, PNO, produce stronger but more condition-dependent effect. In control males and females, it increased centralization around trill cluster, reinforcing a more organized vocal syntax. In VPA males, transitions shifting toward lower pitch calls, so in opposite way. But here we can notice slight increasement in the in links. In the females, PNO promote generally a shift transition toward 50 kilohertz shorts, along with fewer transition into 70 kilohertz shorts, what may suggest a modest normalization of vocal syntax. So generally, to summarize this syntax analysis, VPA exposure simplified the communication in rats. We saw fewer transition and reduced repertoire diversity. PAM treatment partially reversed this effect, increasing transition type, increased transition to the trill type calls, restoring the original cluster transition or enhancing number of links. So our findings highlight the sex-specific vulnerability in VPA model in rats. Males show stronger and more persistent deficit, especially in the call quantity and timing, while female seems to reorganize the communication without major loss in output. Although alpha-7 PABs did not fully normalize communication, they slightly improved the timing and syntax. I think it's subtle, but I think important component of social exchange. So, but to fully confirm the meaning of these changes and their efficacy, of course, we should combine these calls with the social behavior, or maybe try also other timing schedule. Finally, that's the end. And finally, I would like to acknowledge the Polish National Science Center for founding this award and the grant awarded to Professor Nikiforuk. Thank you for your attention. And I just will mention that the last part was published in the Behavioral Brain Research special issue. Thank you.